My dear friend, Namaskar. Welcome you to my YouTube channel DP Forensic Lab. In today's video, I will discuss about the principle of the IR spectroscopy. So, what is IR spectroscopy? When the IR pass through the sample, some part of the IR absorbed and the remaining pass through the samples. The observance or the number of wavelength observed by the sample is depend on the nature of the samples. So, if the sample is different, the observation is different, IR spectra you will get will be different. Any two compound does not have the identical IR. It is very characteristic. Two sample, to any kind of the sample, even you have the same compound, they do not have the similar IR. Suppose you have taken the some drugs, special caffeine or paracetamol and other company. Even the paracetamol is a compound, yeah, but you can identify they will not remain the identical. IR spectra of the two company will not identical. So why this not identical? I will describe or explain in the other video why the two samples having the same compound, same molecular formula, same fungus formula, if they are come from the different source, they does not have the identical IR spectra. So I have explained what is IR spectroscopy. The spectrum analysis of the IR actually. Yeah. If the IR pass through the sample, some part of the IR will observe the samples and remaining transmitted, and the transmit IR can be detected, which can be plotted in a spectrum which called the IR spectrum. Suppose if that sample does not observe any frequencies, so 100% transmitted, you will get the 100% transmitted. So the transmission, your transmittance, this is a percentage of the transmission by axis, this is x-axis, yeah, frequency. So up to this level, suppose like this, and at this, the suddenly the transmittance fall down, because at this frequency, suppose this is a 400 nanometer, this frequency is observed by the samples. So you will get not this frequency in the detector, or the transmission come down. So in this way, the spectra of the IR can be drawn. 100% transmission means no observations. All the radiation is observed to the transmittance in a perfect plan. This is a transmission, as I have explained, or in this is a frequency. I have explained why on the how the IR spectra is formed. Now, when a molecules observe a radiation causing is chemical bond in vibration, when the any material, suppose this is a material, and is observe a particular frequency, and which frequency this material will observe, the frequency observance frequencies depend the frequency of this compound, which are the molecules which are vibrating like a spring model. So this we can take the molecules of any substance not remain in rest position, they are always vibrating. So any vibration generate the frequency. So the vibration frequency can be calculated by the using formula this. Nu is equal to 1 upon 2 pi c under root f time m1 plus m2 upon m1 plus m2, where M1 and M2 are the mass of the two atoms. F is a force constant and C is a velocity of the light. So you can calculate the frequency at which frequency these two items are vibrating. If the frequency of this vibrating molecules match with the frequency of incident IR, then absorbance take place or the molecules absorb that particular frequency. Any molecules, it is a group of atom connected as a bond. We can say like a spring model. So on the basis of the spring model, the frequency can be calculated. So suppose when the energy of the molecules are excited to the high energy state IR absorption, the vibration of the molecules absorption take place. So this is IR spectra, two compound A and B. Okay. And I have told if the frequency incident frequency F is equal to F0. F0 is the frequency of this vibration of these molecules. Then the observation take place. Otherwise, sample will not absorb any wavelength. And this is a now theory of the vibration. Okay. This kind of the graph you will get when you will take the harmonic oscillator model. Suppose, as I explained, if two molecules are connected by the spring and they are vibrating, so the vibration frequency or the energy in the spring, the energy of the potential energy of the spring is varies with the displacement of this spring. Suppose if there is no displacement, there is zero displacement. This is a original position. So the potential energy is equal to 0. And if this increasing, suppose in the plus direction, compressed, yeah, so this is increasing like this, and further if is increasing expansion of the spring in negative direction or the displacement in the other direction, yeah, further the energy is increasing, potential energy increasing. So potential of the increasing in the both cases are increasing, whether the spring is compressed or whether the spring is expanded. In both cases, energy will store in the spring. So this is a parabolic equation or energy, because the energy can be expressed in this formula E is equal to 1 upon 2 k by square, where y is equal to displacement, E is equal to energy. So this is the equation of a parabola. So the energy stored is not a linear form. If linear form means, suppose energy formula is like this: E is equal to ax plus y. So this is a equation of a line. So the store energy follow a parabolic path, not a linear path. Keep in mind. So you will get this type of the spectra. Sorry. Now this is another a graph which or I explain. I will not go in the detail. So and this IR spectroscopy. Uh, there is a one range. The IR spectroscopy or the IR can be categorized or divided in the three group. Near IR, the frequency 4000 to wave number. This is the wave number 14,000. Or mini infrared 4 sorry, 400 say 4000 centimeters inverse, or in the wavelength, this is a 0.7 say to 2.5 micrometer or micron, and this is in the wave number. So this a whole IR range are divided by the three category: NIR, MIR, or FIR. For IR, why or this is because this is categorized because the nature of the observations is depend on the incident of the IR. So in generally in the MIR is a very common or give the very characteristics peaks. So mostly are used for the identification of a sample in the case of the direct identification or other more. uh, in the mid IR, it is definitely you will get the information in case of the near IR or the for IR also. What we generally use this range in forensic purpose, mid IR. So thank you, my dear friends. For further, I will discuss this continue in another video. Thank you.